Have you ever just looked at human behavior, maybe something you did or something you saw, and just thought, why? Why do certain attractions feel so incredibly powerful?
Mm,
Or why does conflict seem to crop up sometimes, even, with people we really care about? Why are we so quick to judge others?
right. These fundamental questions. Are they just quirks
Yeah.
or something deeper?
Exactly. And maybe they aren't just random personality things or purely down to modern life. Maybe they're actually echoes from our really, really deep evolutionary past.
That's precisely the idea. These patterns that feel so personal or, so tied to our current situation, dating apps, family arguments, whatever, often have roots stretching back hundreds of thousands, maybe even millions of years.
And that's why we're doing this deep dive today. We're digging into a really fascinating source, excerpts from a textbook on evolutionary psychology. Our mission basically is to unpack the core ideas, try to understand how our ancient history shaped the actual psychological machinery running inside our heads right now.
Yeah, looking for those aha moments.
Totally. Those moments that give you a completely new perspective on why we humans are, well, the way we are. We're aiming to cut through the dense academic stuff and pull out the key insights for you.
Think of it like getting a new lens, maybe. A biological, historical lens to view almost everything. Your relationships, family stuff, even things like office politics or global conflicts.
Okay, I'm definitely ready for that. Let's dive in. So, where does this whole field applying evolution to the mind, where does it even start?
Well, you absolutely have to start with Charles Darwin. It's kind of amazing, really. Back in 1859, right at the very end of a species, his huge revolutionary book he put in this single sentence, almost like a throwaway line, but so prophetic.
What did it say?
He wrote, in the distant future, I see open fields for far more important researches. Psychology will be based on a new foundation.
Wow. 1859, that's,
Yeah,
yeah, over 150 years ago. He actually predicted that psychology, the study of the mind, would eventually be built on evolutionary theory.
he saw the potential, absolutely. And his own work laid the groundwork with two really key theories. The first one, the one everyone knows, is natural selection.
Survival of the fittest, basically.
Well, yeah, but it's more about reproduction than just survival. It's the process where characteristics that help an organism survive and reproduce successfully in its particular environment become more common over generations. Traits that give you an edge in surviving and, crucially, having offspring get passed on.
Okay, so things like adapting to climate, developing immunity, camouflage.
Exactly. Things like being able to regulate your body temperature, mammals developing fur for warmth, females evolving mammary glands to feed their young. These are all classic examples of natural selection designing adaptations that solve specific survival and reproductive problems. Even huge things like placental mammals evolving around, 114 million years ago? Developing the fetus internally gave big advantages over laying eggs.
Right, survival makes total sense. But Darwin realized that wasn't the only force shaping life, did he? He saw things that didn't seem to help survival at all.
He did. He was puzzled by traits that seemed, counterproductive to just staying alive. The classic example is the peacock's tail. It's gorgeous, sure, but it's heavy, makes the bird easier for predators to spot, harder to escape, and takes a ton of energy to grow. Darwin himself apparently found things like that really bothersome because they just didn't fit neatly into his natural selection idea.
So, if it makes you less likely to survive, how could it evolve? What was his explanation for the peacock's tail, or for why males and females often look so incredibly different in some species?
That led him to his second major theory, sexual selection. This one isn't just about surviving long enough to reproduce. It's specifically about adaptations that help an organism win in the mating game.
Ah, okay. So traits that make you better at attracting a mate, or maybe better at competing with rivals for access to mates?
Precisely. The peacock's tail might be a survival liability, yeah, but it's a huge asset when it comes to impressing the peahens. It signals health and good genes, apparently.
So it might get you eaten by a fox more easily, but it also gets you more dates, more offspring, and passing on genes is the ultimate goal, evolutionarily speaking.
That's the bottom line. The real currency in evolution isn't just staying alive. It's successfully reproducing. Getting those genes into the next generation, whatever works best for that in a given environment.
Okay, I can already see why applying these ideas, especially to humans, would stir up controversy. What were some of the big challenges Darwin's theories faced right from the start?
Oh, huge challenges. On a societal level, just the idea that humans weren't specially created, but shared ancestors with other animals, particularly apes. That was deeply disturbing for many people in Victorian England. You get quotes like Lady Ashley reportedly saying, "Let's hope it's not true, but if it is true, let's hope that it does not become widely known."
Huh, basically. Let's keep this quiet.
Pretty much. And there was Bishop Wilberforce famously trying to ridicule Thomas Huxley in a debate, asking him if he claimed descent from an ape on his grandmother's side or his grandfather's side. Just a lot of cultural and religious pushback.
Ouch. Going straight for the family insult.
Exactly. But there were also real scientific hurdles at the time. Darwin didn't have a correct theory of heredity. He sort of believed in this idea of blending inheritance, like mixing paint's offspring would just be an average of their parents.
Which doesn't really work, does it? Wouldn't that just dilute any new advantageous trait?
Critics rightly pointed that out. It would quickly wash out variation, which is the raw material evolution needs. It really wasn't until Gregor Mendel's work on genetics, on particulate inheritance genes as distinct units, was rediscovered much later in the early 20th century that the mechanism became clear.
So the core idea was there, but the biological nuts and bolts were missing, plus all the social resistance. How do we get from there to modern evolutionary psychology? It seems like there was a long gap.
There was a bit of a slow burn, yeah. But things really started cooking in the late 1960s and early 70s. This built on crucial earlier work, especially by biologists like George Williams, who emphasized thinking about selection acting at the level of genes. And W.D. Hamilton's theory of inclusive fitness. We'll definitely come back to that. But a key figure who really synthesized a lot of this was Robert Trivers.
Trivers, yeah, his name comes up constantly in this field. What were his big breakthroughs?
He was actually a graduate student at the time, which is amazing. He published a series of absolutely seminal papers that basically laid the theoretical foundation for modern evolutionary social science. First, he came up with the theory of reciprocal altruism. This explained how cooperation, help, and behavior could evolve even between unrelated individuals.
The whole "you scratch my back, I'll scratch yours" idea.
Essentially, yes. If there's a system where favors are likely to be returned later, helping someone else can benefit you in the long run, it requires mechanisms to remember who owes whom, and critically, to detect and punish cheaters who take without giving back.
Okay, that explains cooperation beyond just family. What else?
His second huge contribution was parental investment theory. This was groundbreaking because it directly linked Darwin's sexual selection to the amount of time, energy, and resources each sex typically invests in offspring. The core prediction is profound. The sex that invests more biologically in offspring, pregnancy, lactation, etc., will generally be the more discriminating sex when choosing a mate.
Because they have more to lose from a bad choice.
Exactly. The costs are higher. And conversely, the sex that invests less will typically be more competitive with each other for access to the high-investing sex.
But that makes a lot of intuitive sense when you put it like that.
It really does. And his third major theory, maybe the most surprising at first glance, was parent-offspring conflict. This highlights the fact that because a parent and child share only 50% of their genes on average, their evolutionary interests aren't perfectly identical.
Wait, parents and kids have conflicting evolutionary interests, even though they're family.
Absolutely. What's optimal for maximizing the parent's total genetic output across all their potential offspring might not perfectly align with what's optimal for maximizing one specific child's individual success.
Can you give an example?
The classic one Trivers used is weaning conflict. From the baby's perspective, nursing for as long as possible seems ideal. But from the mother's perspective, at some point, her overall fitness might be better served by weaning this child to conserve her resources and potentially become fertile again to have another child. Their genetic interests diverge slightly, leading to conflict over the timing of weaning.
Wow. Okay, so those three theories, reciprocal altruism, parental investment, parent-offspring conflict, they sound foundational.
They absolutely are. They've spurred literally thousands of studies across countless species, including humans, and provided this incredibly powerful framework for understanding social behavior from an evolutionary standpoint.
Okay, so we have the historical roots and the key theoretical pillars, but applying evolution to human behavior, I know it often gets misunderstood. What are the common pitfalls people fall into?
Yeah, that's crucial to address. One of the biggest misunderstandings is genetic determinism. This is the faulty idea that if a behavior is evolved, it means it's rigidly hardwired by genes and happens automatically no matter the environment. That's just flat out wrong.
So it's not like our genes are pulling puppet strings and we just dance.
Not at all. Genes always require input from the environment to actually build an organism and produce behavior.
Think about calluses on your hands or feet. We clearly have evolved genes that allow skin to thicken in response to friction. That's an adaptation.
Right.
But you don't just get calluses spontaneously. They develop only if your skin experiences repeated rubbing or pressure. The genetic potential is there, but the environmental trigger, the friction, is absolutely necessary.
That's a great way to put it. The environment activates the genetic potential. Exactly. And this leads directly to the second major misunderstanding. The idea that if something is evolved, it's immutable, meaning it can't be changed. Again, back to calluses. Once you understand that friction triggers the evolved callus-forming mechanism, well, you gain power. You can change the environment, wear gloves, use different tools, avoid the friction.
So understanding the evolved mechanism actually gives you more control, not less.
Precisely. Knowledge of our evolved psychology, including the environmental cues that activate specific mechanisms, gives us more power to shape outcomes and make conscious choices. It's about understanding the design, including how that design interacts with the world.
That completely flips the script on how some people view evolution and behavior. So
Yeah.
if we're looking at the mind through this evolutionary lens, what are the actual things produced by evolution? What are we looking for?
The main focus for evolutionary psychologists is on adaptations. These are the core products. As we said, they are inherited characteristics that reliably developed in our ancestors because they consistently help solve specific problems related to survival or reproduction. They typically have a genetic basis, often involving many genes working together. They are complex in their design for a specific function, and they require environmental input to develop and activate properly.
Like the eye, complex design solves the problem of seeing, needs light to work.
The eye is a perfect example of a complex biological adaptation. In psychology, we're looking for psychological adaptations, information processing mechanisms shaped by selection. But there are other products too. There are byproducts.
Byproducts, like side effects.
Sort of, yeah. These are characteristics that don't actually solve any adaptive problem themselves and don't really show evidence of functional design, but they get carried along because they're linked to an adaptation that is functional. The textbook uses the analogy of a lamp designed to produce light. That's the adaptation. But the lamp also produces heat. The heat isn't what it was designed for. It's just a byproduct of the process of generating light.
Ah, okay. Like the belly button, it's just left over from the umbilical cord, which was an adaptation.
Exactly. The umbilical cord was crucial for fetal survival. The belly button is just the scar left behind.
Oh.
It doesn't seem to do anything functionally now. It's a byproduct. So when we look at any trait or behavior, the question is, does it show signs of complex functional design for solving a specific ancestral problem, adaptation? Or does it seem more like it just came along for the ride with something else, byproduct?
Got it. Function versus, well, just being there.
Pretty much.
Right.
And adaptations are the main focus because they tell us about the problems our minds were shaped to solve. Now, when scientists actually investigate these things, they often follow a kind of logical structure, moving from broad theories down to specific tests.
Like a hierarchy?
Exactly. The source describes it like this. At the very top, you have general evolutionary theory, the big principles like natural selection and sexual selection, universal stuff. Below that, you have middle-level evolutionary theories. These take the general principles and apply them to broader domains of life. Travers' theories we just discussed, parental investment, reciprocal altruism, parent-offspring conflict, are perfect examples. They provide a framework for understanding whole areas like mating or cooperation or family dynamics.
So they narrow the focus to a specific set of problems.
Right. And from those middle-level theories, researchers derive specific evolutionary hypotheses. For example, from parental investment theory, you might hypothesize that because human females have a higher minimum obligatory biological investment in offspring, pregnancy, birth, nursing, they will generally be more selective than males when choosing a long-term mate.
Okay, that's a specific, testable idea derived from the broader theory.
Exactly. And the final step is generating specific predictions from that hypothesis. These are things you can actually go out and measure in the real world. So, from the hypothesis that women are choosier in long-term mating, you might predict. 1. Women will state that a potential partner's financial prospects are more important than men do. 2. Women will have higher minimum standards for things like intelligence or social status in a long-term partner compared to men. 3. Women might require a longer courtship period before agreeing to sex compared to men. These are concrete predictions you can test empirically.
That's called the top-down approach, right? Theory to hypothesis to prediction.
Yep. That's a common way evolutionary hypotheses are generated and tested. It provides a really rigorous way to link broad evolutionary principles to specific, observable human behaviors.
So how do they actually gather the evidence? What kinds of data do evolutionary psychologists use to test these predictions?
Oh, a whole range of things. Archaeological records are super important for understanding the environments and challenges our ancestors faced. Analyzing fossils tells us about diet, diseases, injuries. Looking at bone fragments lets us trace things like the evolution of brain size, which, by the way, shows a really rapid expansion in our lineage, especially between about 500,000 and 100,000 years ago.
So clues from the deep past about the problems they had to solve.
Exactly. Then you have observations of behavior in contemporary human societies, especially looking across different cultures to see patterns. Self-reports through questionnaires and interviews are widely used to get at people's preferences, thoughts, and feelings. Public records, marriage rates, divorce statistics, crime data can provide valuable large-scale information. Even looking at artifacts like ancient tools, seeing the progression from crude stone tools maybe 800,000 years ago to sophisticated Acheulean hand axes 1.5 million years ago, or wooden spears maybe 500,000 years ago, tells us about their increasing cognitive abilities and the problems they were tackling.
And genetic data too, right? Like the out of Africa evidence.
Absolutely. Modern genetic data provides powerful evidence. For instance, the relatively low genetic variation found in human populations outside of Africa, compared to the higher variation within Africa, strongly supports the theory that modern humans originated in Africa and then migrated out, experiencing population bottlenecks along the way. It confirms our shared, relatively recent ancestry.
It sounds like a really interdisciplinary field, pulling from anthropology, biology, genetics, psychology.
It absolutely has to be. And another really key development that helped pave the way was the cognitive revolution in psychology, starting around the mid-20th century.
That was the shift away from pure behaviorism towards studying the mind itself.
Exactly. Psychologists started seriously thinking about internal mental processes, thoughts, beliefs, memory, attention. The mind came to be seen as an information processing system, kind of like software running on the hardware of the brain.
Okay, the mind processes information. But evolutionary psychology has a pretty specific view on how that processor is organized, doesn't it? Different from earlier cognitive science.
Yes, this is a crucial distinction. A lot of early cognitive psychology tended to assume the mind was like a general-purpose computer,
Oh.
equipped with a few powerful, content-free learning rules that could be applied to anything. Learn language, recognize faces, figure out physics, all with the same basic toolkit.
One size fits all.
Kind of, yeah. Evolutionary psychology argues for a very different picture. A mind composed of a large number of specialized mechanisms, sometimes called modules. Each of these is like a dedicated mini-program designed by evolution to solve a specific recurrent adaptive problem faced by our ancestors.
So not one big hammer, but a whole toolbox full of specialized tools. One for language, one for mate choice, one for spotting danger, one for understanding social rules.
That's the core idea. The reason for this problem specificity is that what counts as a good solution is different for different problems. Detecting a snake in the grass needs a fast automatic system. Choosing a reliable, trustworthy long-term partner requires evaluating complex social cues over an extended period. A general-purpose mechanism would likely be too slow, too error-prone, or just wouldn't work for many of these distinct challenges.
That makes sense. You need different algorithms for different jobs.
Right. And this ties into what's called computational theory. The idea is that to really understand any cognitive mechanism, you first have to figure out its function. What adaptive problem did it evolve to solve? And why was solving that problem important for survival and reproduction back then? It anchors the study of the mind in its evolutionary purpose.
Okay, so just to recap, we've got Darwin's big ideas, natural and sexual selection. We have the foundational theories from Trivers, like parental investment. We understand we're looking for adaptations, not byproducts. There's a clear way to generate hypotheses, top-down. We use diverse data from fossils to surveys. And the mind isn't a blank slate or a single computer, but more like a collection of specialized tools designed to solve ancient problems.
That's a great summary. And that brings us squarely to looking at those specific sets of problems our ancestors faced, starting with the most basic challenge of all, just staying alive.
Right. Problems of survival. What were the big threats they were constantly dealing with?
Well, the hostile forces of nature, as the textbook calls them, were relentless. Finding enough food, avoiding poisons and toxins, escaping predators, fighting off parasites and diseases, dealing with extreme weather. It was tough, and getting enough food was probably the most constant day in, day out challenge.
We evolved as omnivores, right? Eating both plants and animals, that gives flexibility but also creates risks.
Precisely. Being able to eat lots of different things is great when food is scarce, but it also means you might encounter things that are poisonous or contaminated. So we evolved specific food-related psychologies. We have strong preferences for calorie-dense foods, things like fats and sugars, because calories were often scarce and vital for energy ancestrally.
Our sweet tooth has deep roots.
It certainly seems so. But just as importantly, we evolved powerful mechanisms to avoid harmful things in food.
Like the emotion of disgust. That feeling when you see moldy food or smell something rotten.
Disgust looks like a prime candidate for an evolved defense system against pathogens and toxins. Think about what triggers it. Rotting meat, spoiled fruit, feces, open sores, insects associated with disease, all things that could make you seriously ill if ingested or touched.
It feels like an automatic stay-away signal.
Research backs that up. Things that reliably trigger disgust are often linked to disease transmission. The reaction seems universal across cultures. And feeling disgusted can even activate parts of your immune system, like slightly raising body temperature, as if preparing for a potential infection.
Wow. So that yucky feeling isn't just subjective, it's an ancient protective mechanism.
It really looks that way. And beyond just avoiding bad food, we have reflexes to expel things that do get in or near our bodies. Gagging, spitting, vomiting, coughing, sneezing, even diarrhea could be seen as ways to quickly get rid of ingested toxins or pathogens.
Even morning sickness during pregnancy.
That's a fascinating hypothesis. Pregnancy sickness, especially in the first trimester when the fetus is most vulnerable, might be an adaptation to make the mother avoid foods that could contain toxins harmful to development. It's debilitating, but it might serve a protective function.
Nature really built in layers of defense. What about spices? I've heard theories about why we use them.
Yeah, the antimicrobial hypothesis is intriguing. It suggests that many spices we use contain compounds that kill or inhibit the growth of bacteria and fungi, especially in meat dishes which spoil easily. Cultures that historically used more spices, especially in hotter climates where food spoils faster, might have had lower rates of foodborne illness. This practice could then spread culturally because it conferred a real survival advantage.
So spicy food might have started as a form of food preservation.
Possibly, yeah. Even our taste for alcohol might have ancient roots. Maybe it comes from our primate ancestors eating ripe, fermented fruit, which has low levels of ethanol.
And fire. Cooking must have been a complete game changer for food.
Oh, absolutely massive. The control of fire, which might go back as far as 1.6 million years ago with Homo erectus in Africa, revolutionized everything. Cooking makes food safer by killing parasites and bacteria. It makes tough fibers and starches more digestible. It unlocks more calories and nutrients from the same amount of food. This energy boost is thought by many to be a critical factor that allowed for the evolution of our large, energy-hungry brains.
Okay, so getting food and avoiding bad food was huge. What about avoiding becoming food? Or other physical dangers?
Right, dealing with predators and other environmental threats was another major selective pressure. When faced with an immediate danger, like a predator appearing, humans, like many animals, show a kind of predictable sequence of responses. First, you freeze. Stop moving, stay quiet. Try not to be detected while you assess the situation.
Makes sense. Don't draw attention.
If that fails, and you are detected, the next step is usually flee. Get away as fast as possible. If you can't escape, then you fight. Defend yourself aggressively. And if fighting is hopeless, sometimes there's a final response. Fright or tonic immobility, essentially playing dead, which can sometimes cause a predator to lose interest.
Freeze, flee, fight, or faint. Is fainting part of that?
Fainting is interesting because it seems more uniquely human, or at least more common in humans, in response to extreme psychological stress, not just physical injury. One hypothesis is that it might have evolved relatively recently in human evolution, perhaps in the context of intense interpersonal violence or warfare, where suddenly collapsing might signal non-threat or injury and reduce the chance of being killed.
Fainting as a potential survival strategy, that's unexpected.
It's a hypothesis, yeah. We also seem to have evolved specific fears. We learned very quickly, almost instinctively, to fear things that were consistent threats in our ancestral past. Things like snakes, spiders, heights, deep water.
But not modern dangers like cars or guns.
We can learn to fear those, obviously, but it doesn't seem to be as prepared or automatic. Our fear learning system seems biased towards ancient dangers. Studies show our visual system is incredibly fast at spotting snakes and spiders, even when hidden in complex images. It's like our brain is still running Savannah threat detection software.
Still scanning the grass, not the intersection.
Seems like it.
There are other subtle biases too. The vertical descent illusion. We tend to perceive heights as greater when looking down than when looking up the same distance. This might be an adaptation to make us more cautious about potentially fatal falls.
Makes you think twice before stepping off the ledge.
Exactly. Or the auditory looming bias. We tend to overestimate how close an approaching sound source is compared to a receding one. This would make you react faster to something coming towards you, giving you a better chance to escape. We're also really good at learning which animals are dangerous just by watching how others react to them, prepared social learning.
So it's a whole package of adaptations, reflexes, biases, learning systems, all geared towards staying safe.
It really is. And this evolutionary viewpoint is even starting to influence medicine in a field called Darwinian medicine. It looks at symptoms like fever, inflammation, or even low iron levels during infection, not just as problems, but potentially as the body's evolved defenses against pathogens. Maybe fever helps cook the bacteria, or reducing iron starves them.
Fascinating. Okay, so survival was job one, but Darwin taught us that just surviving isn't enough. You have to pass on your genes. You need to reproduce. Which brings us to
The challenges of sex and mating. And this is where Robert Trivers' parental investment theory really takes center stage. Remember the two big predictions?
Yep. The sex that invests more biologically in offspring, usually females, will be the choosier one when picking a mate. And the sex that invests less will compete more intensely for access to the high-investing sex.
Spot on. Now for humans, especially thinking ancestrally where raising a child to adulthood was incredibly difficult, it typically required massive investment from both parents over many years. So for long-term mating, like marriage, we'd expect both men and women to be pretty selective.
Makes sense. High stakes for both.
But there's still that fundamental biological asymmetry. Women have the higher obligatory investment pregnancy, childbirth, lactation. This difference sets the stage for slightly different, evolved mating strategies, even in the context of long-term relationships. Let's look at men's long-term mating strategies first. What's a key problem an ancestral man faced when looking for a wife?
Knowing if she could actually have children. Fertility, especially since ovulation is hidden in humans.
Exactly. Unlike many primates, human females don't have obvious physical signs when they're ovulating, so men couldn't just target fertile periods. Instead, the hypothesis goes, men evolved psychological preferences for cues that were reliably associated with a woman's fertility or reproductive potential over the long term.
What kind of cues?
Well, one of the strongest and most universal cues is youth. Female fertility peaks in the early to mid-20s and declines thereafter. And consistently, across dozens of diverse cultures, studied 37 cultures in one famous study, men expressed a preference for younger wives. The average preferred age difference was about 2.5 years younger, but the preference for youth itself was found everywhere, from Nigeria to China to Canada.
That consistency across cultures is pretty striking evidence for an evolved preference.
It really is. Eye-tracking studies even show that men's attention is automatically captured by younger female faces more than older ones. Another major category of cues relates to physical appearance, which can signal health and youth, and therefore reproductive potential. One specific measure that's gotten a lot of attention is the waist-to-hip ratio, or WHR.
Right, the hourglass figure idea.
Proposed by Devendra Singh, yeah. A relatively low WHR, around 0.7, where the waist is significantly narrower than the hips, is consistently rated as attractive by men across cultures. And importantly, this ratio is linked to actual health and fertility outcomes. Women with lower WHRs tend to be healthier, have fewer endocrine problems, and conceive more easily. So the preference likely evolved because WHR was an honest signal of reproductive capability.
So men's brains are essentially wired to find signs of youth, health, and fertility attractive in a long-term partner.
That's the argument. And it's not just WHR, but other aspects of facial and body features that correlate with youthfulness and health. Now, here's where it gets interesting. These male preferences have likely shaped female behavior and even female preferences in turn. Think about appearance enhancement. Women across cultures invest vastly more time, effort, and resources in enhancing their appearance than men do makeup, hairstyling, clothing choices, dieting. Why?
Because those things emphasize the cues that men find attractive. Youthfulness, clear skin, maybe accentuating that waist-to-hip ratio.
Exactly. Women's tactics often seem designed, consciously or unconsciously, to amplify precisely those cues that tap into men's evolved preferences. It's like a co-evolutionary feedback loop. And men's preferences demonstrably influence their behavior too.
Okay, so Men are looking for cues to fertility. What other big problems did men face in long-term mating?
A huge one, especially given concealed ovulation and internal fertilization, is paternity certainty. If a man is going to invest years of resources and protection into children, evolution would strongly favor mechanisms that increase his confidence that those children are actually his genetic offspring.
How could ancestral men increase that confidence?
The institution of marriage, viewed through an evolutionary lens, looks very much like an evolved solution, or at least a cultural universal that addresses this problem. Marriage traditionally provides relatively continuous sexual access, increasing the odds of conception. It involves public commitment and social monitoring, which can discourage infidelity, and living together allows partners to learn each other's patterns and potentially detect deviations. Some even argue that concealed ovulation itself might have evolved to promote pair bonding, because a male would need to stick around and mate repeatedly throughout the cycle to have a good chance of fathering offspring.
That's a really interesting twist. Concealed ovulation making long-term bonds more likely. Okay, let's flip it. What about women's long-term mating strategies? What were their primary adaptive problems?
For ancestral women, facing the huge biological costs of pregnancy and lactation, and often being more vulnerable while caring for young children, a critical challenge was securing a reliable flow of resources and protection for herself and her offspring.
So they'd be looking for a partner who could provide and protect. A good provider.
Precisely. The hypothesis, again strongly supported by cross-cultural research, is that women evolved preferences for men who display cues of ability and willingness to invest resources. Since you can't always directly see a man's bank account, especially ancestrally, women look for cues correlated with a resource acquisition potential.
Like what? Ambition, intelligence.
Exactly. Things like social status, signs of intelligence, ambition, industriousness, dependability, and often older age, as age tends to correlate with accumulated resources, knowledge, and status. Women consistently rate these kinds of qualities as more important in a long-term partner than men do.
So broadly speaking, men prioritize cues to reproductive capacity, women prioritize cues to resource capacity.
For long-term mating, that's a well-supported pattern rooted in that fundamental difference in parental investment.
Okay, that covers long-term strategies. But humans don't only engage in long-term mating. What about short-term mating strategies? Do the evolutionary pressures differ there?
Oh, significantly. The potential costs and benefits, and thus the adaptive problems to be solved, look quite different when considering casual or short-term sexual relationships. Let's start with men's short-term mating.
What's the potential evolutionary payoff for men?
From a purely reproductive standpoint, ancestrally, the direct benefit for a man engaging in short-term mating could be straightforward. An increase in the number of offspring produced, potentially with little or no investment required beyond the act of insemination.
So potentially higher reproductive success through quantity over quality.
That's the basic logic. And the evidence for a stronger male desire for sexual variety compared to women is really quite overwhelming. It's one of the largest and most consistently found psychological sex differences across cultures. Men, on average, report desiring significantly more lifetime sexual partners than women do.
How many more?
The numbers vary, but often dramatically more. Men also report needing less time to elapse before consenting to sex. They lower their standards considerably for a short-term partner compared to a long-term one, especially regarding things like intelligence or personality. They report more frequent and varied sexual fantasies, often involving strangers, multiple partners, or anonymous encounters. Some studies found men fantasizing about over 1,000 different partners in their lifetime.
1,000?
Yeah. Men also report a higher overall sex drive, are more likely to regret missed sexual opportunities rather than sexual encounters they had, are statistically more likely to engage in extramarital affairs or seek out purely sexual hookups, and they're overwhelmingly the clients in the global sex industry.
That's a pretty comprehensive list pointing towards a strong evolved male desire for sexual variety.
It is.
Yeah.
And there's even physiological evidence that aligns with this. If you compare test size across primates relative to body size, it correlates with the typical mating system. Species where males typically monopolize females, like gorillas, have relatively small tests, not much sperm competition.
Right.
Species where females routinely mate with multiple males during a cycle, like chimpanzees, have very large tests, intense sperm competition. Humans, we're intermediate. Our tests are larger than gorillas but smaller than chimps. This suggests a history where females weren't completely monopolized and engaged in enough short-term or extra-pair mating that some level of sperm competition was a recurring evolutionary pressure. It implies both sexes pursued short-term mating sometimes, but perhaps not to the extent seen in chimps, and likely with different underlying psychologies.
So our biology reflects a mixed mating strategy in our past.
It seems to. Men also appear to have evolved specific psychological mechanisms for identifying potentially receptive short-term partners, sometimes called cues to sexual exploitability. Research suggests that men, particularly those who are more oriented towards short-term mating themselves, find certain cues in women, like perceived immaturity, intoxication, recklessness, sometimes even signs of vulnerability, as attractive specifically for a short-term encounter, while finding these same cues unattractive in a potential long-term mate.
That's kind of disturbing. It implies a mechanism designed to target perceived ease of access, separate from long-term mate value.
It does highlight how context-specific mating psychology can be, and yes, some implications are unsettling. It suggests an evolved sensitivity to cues of short-term sexual accessibility when that's the goal. There's also the related closing time phenomena, the observation that as the night wears on in a bar or social setting, people, especially men, tend to rate the remaining potential partners as more attractive, perhaps linked to dwindling opportunities.
Okay, so men's short-term strategy seems geared towards maximizing mating opportunities. What about women's short-term mating? The risks seem much higher for women: unwanted pregnancy, damage to reputation, potentially lower investment from a future long-term mate.
Absolutely. The potential costs were significant ancestrally. Raising a child alone was incredibly difficult and dangerous. However, short-term mating wasn't necessarily always disadvantageous. There could have been potential benefits that, in certain circumstances, outweighed the costs.
What kind of benefits?
Several hypotheses exist. One is the good genes, or sexy son hypothesis. A woman might engage in a short-term affair with a man who is particularly physically attractive or dominant, even if he offers no commitment, potentially to acquire superior genes for her offspring. If her sons inherit these sexy traits, they might be more successful in attracting mates themselves in the next generation, thereby boosting the mother's indirect reproductive success.
So getting good genetic material even without partnership.
That's the idea. And studies do show women tend to place a higher priority on physical attractiveness in a short-term mate compared to a long-term one. Another possibility is the resource accrual hypothesis. Short-term mating might have been a way for some women to gain immediate access to resources, food, gifts, protection perhaps, as a way to supplement resources from a long-term partner or survive during times when they lacked a committed partner. Research suggests women sometimes elevate the importance of immediate generosity and extravagant displays in short-term partners.
Okay, so potential genetic benefits or immediate resource gains could sometimes make short-term mating adaptive for women too, despite the risks.
That's the thinking. So while the frequency and primary motivations might differ between the sexes, evolutionary theory suggests both men and women possess adaptations related to short-term mating, activated under different circumstances.
And because these strategies and desires aren't always perfectly aligned, that's where sexual conflict comes in.
Exactly. When the evolutionary interests or optimal strategies of males and females diverge, you get conflict. This can manifest in many ways.
Like sexual harassment.
That's one example. Statistically, sexual harassment is overwhelmingly something men do to women, and women report experiencing far greater distress from unwanted sexual advances than men typically do. This makes sense from an evolutionary perspective, given the potentially higher costs for women of unwanted sexual encounters or relationships. Data from workplace surveys and human rights commissions consistently shows this pattern.
And again, understanding the potential evolutionary roots isn't justifying the behavior, right? It's about identifying the underlying psychology to better address it.
Absolutely crucial point. Understanding is not excusing. The goal is prevention and mitigation. A much darker area of sexual conflict involves sexual aggression and rape. Women are universally more psychologically harmed by sexual coercion than men. There's a very complex and sensitive debate among researchers about the evolutionary origins of rape. Is it a specific adaptation, meaning a psychological mechanism designed specifically for coerced sex under certain conditions? Or is it primarily a pathological byproduct of other male adaptations, like the strong desire for sexual variety, combined with a general capacity for aggression and lack of empathy in some individuals?
That sounds like a really difficult question to answer scientifically.
It is. The source material points out that current evidence, for example, the fact that rape victims are often young and fertile, is actually consistent with both hypotheses. Men prefer young, fertile women in consensual contexts too, so victim characteristics don't uniquely point to a specific rape adaptation. The authors rightly stress the urgent need for more research from multiple perspectives to understand the deep causes, identify factors that increase risk, like certain personality profiles or developmental histories in perpetrators, and ultimately develop effective strategies to prevent and eliminate sexual assault.
That focus on understanding for prevention seems vital. What other forms does sexual conflict take?
Sexual jealousy is a huge one and a powerful trigger for conflict and even violence. Specifically, male sexual jealousy, particularly a man's suspicion or perception that his partner might be unfaithful, is one of the strongest predictors of violence against female partners across cultures.
It's the suspicion more than the reality sometimes.
Studies suggest the man's perception or insecurity about potential rivals is often a more potent predictor of his aggression than the woman's actual behavior. Men who constantly accuse their partners of infidelity are at much higher risk of becoming violent. Pregnant women, sadly, seem particularly vulnerable, perhaps because pregnancy makes paternity stakes especially salient. Certain mate retention tactics behaviors aimed at keeping a partner, especially controlling ones like monopolizing her time, isolating her from friends and family, or threatening rivals, are strongly linked to physical violence.
That sounds like a pattern of control escalating to violence.
It often is. And one of the most chilling findings in this area, first highlighted forcefully by Martin Daly and Margot Wilson and confirmed by later research, involves stepchildren. The presence of stepchildren in a household dramatically increases a woman's risk of experiencing violence, including lethal violence, from her male partner.
Wow, that starkly highlights the role of genetic relatedness, doesn't it? Which seems like a natural transition to the next big area,
Yeah,
the challenges within families.
absolutely. That brings us to the challenges of parenting and kinship. This dives into the evolutionary dynamics of family life, focusing on how natural selection has shaped mechanisms for parental care and cooperation among relatives. And just as you said, a absolutely fundamental principle here is sensitivity to genetic relatedness.
This goes back to Hamilton's inclusive fitness idea. We're wired to invest more in those who share our genes.
Precisely. And maybe the most dramatic, though often uncomfortable evidence for this in humans comes from comparing step-parents versus genetic parents. Consistently, studies find that, on average, step-parents report feeling less positive towards their stepchildren, interact with them less, and experience more conflict in those relationships compared to genetic parents with their biological children.
And the risk of abuse.
The data from Daly and Wilson is stark and deeply sobering. Children living with one genetic parent and one step-parent are at a massively elevated risk of serious physical abuse. Figures often cited are around 40 times higher, and even homicide, potentially 40 to 100 times higher compared to children living with both biological parents.
That's horrifying. How do Daly and Wilson interpret that? Not as an adaptation for abuse, surely.
No, definitely not. They argue that lethal abuse by step-parents isn't an adaptation itself, but rather a tragic, extreme outcome stemming from the generally lower levels of protective parental solicitude and investment that step relationships entail compared to genetic parent-child bonds. Child homicide, in their view, acts as a kind of brutal assay or indicator of the underlying difference in parental feeling tied to genetic relatedness.
A very difficult finding, but it powerfully supports the theory's predictions about relatedness and investment.
It's a profound insight, yes. For men specifically, paternity certainty continues to be a factor influencing investment within biological families. There's this folk wisdom and some supporting research that people are more likely to say a newborn resembles the father. This could be a subtle psychological phenomena, perhaps influencing the father's perception of relatedness and his subsequent willingness to invest.
Like reassuring the dad.
Potentially. More concretely, studies show fathers invest more in things like college education for their genetic children compared to stepchildren, and even among genetic children, investment tends to be higher when the father feels more certain about his paternity. Also, some of a father's investment might function partly as mating effort. Investing in the kids helps maintain the relationship with the mother rather than pure parental effort. This might help explain why relationships between fathers and children often suffer more drastically after divorce compared to mother-child relationships.
Okay. And comparing mothers and fathers directly in terms of investment.
Because maternity is always certain, while paternity can be uncertain, women have, on average, 100% certainty of their genetic relatedness to their offspring. This biological reality likely underpins the general finding that mothers, across cultures, tend to provide more direct, hands-on parental care than fathers, on average. Women also show stronger attentional biases towards infants, are typically better at recognizing infant emotions, and research suggests women are more likely to employ a tend-and-befriend strategy under stress-protecting offspring and building supportive alliances with other women compared to the male fight-or-flight response.
So, biology pushes mothers towards higher average investment. What else shapes how much parents invest? Is it just about relatedness?
No, parents are also evolved to be sensitive to offspring viability. That is, the likelihood that a particular child will survive and eventually reproduce successfully themselves. The idea is that parental investment will be channeled more towards offspring who are most likely to convert that investment into future reproductive success.
So, investing where it's most likely to pay off in evolutionary terms.
That's the logic. Sadly, this means that negative indicators of viability, like severe congenital abnormalities or extreme prematurity, have historically been associated with higher rates of parental neglect or even infanticide in some cultures and situations. Again, infanticide isn't seen as the adaptation, but as a tragic outcome when perceived viability and potential fitness return on investment are extremely low. More generally, studies show parents tend to feel more positive towards and invest more resources in their healthier children compared to those with chronic health issues.
It sounds harsh, but it follows the evolutionary logic of maximizing reproductive success with limited resources.
It does. Parents are also sensitive to the alternative uses of their resources. The time, energy, food, and protection given to one child can't be used for other things that might enhance the parent's overall fitness, like having more children later, investing in their own survival, or helping other relatives.
This trade-off influences decisions.
It seems to, especially in harsh ancestral conditions. This is relevant to understanding patterns of infanticide based on maternal age and circumstances. Rates tend to be highest among very young mothers, who typically have fewer current resources, but many potential future reproductive years ahead of them. Rates are lowest among older mothers who have fewer future reproductive opportunities. Marital status is also critical. An unmarried mother, especially ancestrally, faced enormous challenges raising a child alone and might have faced a grim choice between investing in the current infant with poor prospects versus abandoning or killing the infant to preserve her resources and seek a mate who could help her raise future children under better conditions. Daly and Wilson's work powerfully highlights how maternal age and marital status interact to influence these life or death decisions.
A really stark reminder of the brutal realities ancestral parents sometimes faced. What about biasing investment based on the child's sex? Is there a theory for that?
Yes, the Trivers-Willard hypothesis. It predicts that parents who are in good condition, healthy, high status, lots of resources, might be evolutionarily inclined to bias their investment slightly towards sons. This is because a high-status son, ancestrally, could potentially achieve enormous reproductive success by mating with many females. Parents in poor condition, however, might bias investment towards daughters because female reproductive success, while perhaps having a lower ceiling, was generally more reliable and less dependent on acquiring high status or resources. A daughter was more likely to reproduce at all, even if her parents were poor.
So, bet on the son if you can give him a big advantage. Bet on the daughter for a safer return if resources are tight.
That's the core logic. Testing it in humans is tricky, and the evidence is mixed. But some findings are suggestive. Historical patterns of female infanticide sometimes being higher in elite classes, perhaps favoring sons, some modern studies finding lower-income families investing relatively more in daughters' education, or data showing high-status men sometimes siring slightly more sons than daughters. It's an active area of research.
Okay, moving beyond direct investment, what about that theory of parent-offspring conflict again? Where else does that tension play out in families?
Remember, the conflict stems from that 50% genetic overlap interests aren't perfectly aligned. It predicts conflict will be most intense over issues where the genetic interests diverge most sharply. Empirical studies generally support this. The degree of conflict often maps onto the degree of genetic difference in the optimal outcome for parent versus child.
Where do we see this clearly in human families, besides weaning?
A really common area is conflict over mating choices. When young adults start dating and bring potential partners home, parental approval is often a major hurdle. Why the conflict?
Different priorities.
Exactly, stemming from those asymmetric benefits. The young person stands to gain enormously if their chosen partner has fantastic genes or great resource potential. They are 50% related to any resulting grandchildren. The parents, however, are only 25% related to those grandchildren. So while they care about the quality of their child's mate, their evolutionary payoff isn't as high or direct as the child's. Parents might also have their own agendas, trying to steer their children towards mates who form beneficial alliances for the family, political, economic, which might not align with the child's romantic preferences. Think of historically common arranged marriages among elites.
Or parents might just disapprove of a child's short-term mating strategy.
Yes, if the child is pursuing short-term relationships that could potentially damage the family's reputation or social standing, that imposes a cost on the parents, leading to conflict over the child's mating behavior.
So dating drama has deep evolutionary roots. What about siblings? Is there conflict there too?
Oh, definitely. Sibling conflict is also shaped by evolutionary dynamics, particularly competition for limited parental investment. Frank Sulliway's theory about birth order effects is really interesting here. He argues that because parents don't treat all children exactly the same, siblings adapt to different niches within the family based on their birth order.
How does that work?
Firstborns, who typically receive undivided parental attention early on and often identify more strongly with parents and authority, tend to be more conservative, responsible, and supportive of the status quo. They have the most to gain from maintaining the existing family structure where they were initially favored.
Okay, the conformists.
Often, yes. Laterborns, especially middle children, who might receive less unique parental investment than firstborns or lastborns, have less stake in the current system and more to gain by challenging it. They tend to be more rebellious, unconventional, risk-taking, and open to experience. Studies generally support these personality differences.
And the youngest?
The youngest might sometimes receive renewed parental investment, as parents invest in their last shot at reproduction, potentially leading to different dynamics than for middle children, who might feel squeezed.
That's a fascinating evolutionary take on why siblings can be so different. Okay, broadening out from the immediate family, what about kinship in general?
This brings us right back to William Hamilton's inclusive fitness theory. It's the bedrock for understanding cooperation and conflict among relatives.
The idea that helping relatives helps your own genes.
Precisely. Altruism toward kin can evolve, because your relatives carry copies of your genes by descent. Helping them survive and reproduce effectively increases the representation of your genes in the next generation. This is your inclusive fitness, your direct fitness, your own kids, plus your indirect fitness, the reproductive success of your relatives, weighted by how closely related they are to you.
So evolution favors helping kin, especially close kin.
Yes, the theory makes clear predictions. Altruism should be preferentially directed towards closer relatives who share more genes, and towards relatives who are in the best position to actually convert that help into increased survival and reproduction. For example, helping a healthy young sibling might have a bigger fitness payoff than helping a very old or terminally ill relative. Patterns of cooperation and conflict should generally follow lines of genetic relatedness, more cooperation, less conflict among closer kin.
And we see this in practice. People rely on close family in times of crisis.
Overwhelmingly, yes. When the chips are down, people typically turn to parents, children, and siblings first. Conflicts, while they happen, tend to be less intense and more easily resolved among close kin compared to distant kin or non-relatives. There's also an interesting prediction about kinship and altruism encouragement. Older relatives often have a stronger genetic interest in encouraging younger relatives to be altruistic towards other relatives, like cousins, nieces, nephews, than those younger relatives might naturally feel themselves.
Why is that?
Because the older relative is often more closely related to both parties involved than the younger relatives are to each other. For example, your grandmother is equally related, 25%, to you and your first cousin. You, however, are only 12.5% related to that cousin. So your grandmother has a stronger inclusive fitness interest in you helping your cousin than you might inherently feel based on your relatedness alone. She might encourage more cooperation between you two than you'd spontaneously offer.
That's a subtle but powerful prediction about intergenerational influence.
It is. And underpinning all of this, humans must have evolved kin detection mechanisms, ways to assess cues of relatedness, like childhood co-residence, facial similarity, smell, which help regulate both altruism, directing help appropriately, and inbreeding avoidance, preventing costly mating with close relatives.
Okay, so we've covered survival, mating, parenting, kinship, the core challenges of individual and family life. But humans are hypersocial. We live in groups. What about the evolutionary challenges that arise from group living?
That takes us to the problems of group living. And perhaps the most fundamental challenge here is explaining altruism toward non-relatives. Inclusive fitness explains why we help kin, but why would we ever perform costly acts that benefit unrelated individuals?
This is where reciprocal altruism comes back, right? The scratch my back idea.
Exactly. Triver's theory of reciprocal altruism is key here. It proposes that adaptations for helping non-kin can evolve if the help is likely to be returned in the future. It's about mutually beneficial exchange over time. The classic example is hunters sharing a large kill. The successful hunter has more meat than they can eat. Sharing with an unsuccessful hunter today is low cost, but yields a potentially high future benefit when the situation is reversed. Both hunters do better in the long run through reciprocity than if they were strictly selfish.
But the big problem is cheaters, right? People who take the help but never give back.
Precisely. The problem of cheating is the main obstacle to the evolution of reciprocity. If cheating goes undetected and unpunished, it undermines the whole system. Therefore, selection should strongly favor psychological mechanisms designed to detect cheaters and motivate punishing them or avoiding future interactions with them.
And do we have evidence for such cheater detection mechanisms?
Yes, quite compelling evidence. According to social contract theory, developed by Lita Kosvides and John Tooby, humans have evolved a specialized suite of cognitive adaptations specifically for reasoning about social exchange. This includes abilities like recognizing individuals, tracking histories of interaction, who helped whom, who defaulted, communicating needs, understanding others' needs, and representing the costs and benefits involved. Crucially, studies show people are much better at solving logical reasoning problems when they are framed as detecting someone violating a social contract. For example, taking a benefit without paying the required cost, compared to solving the identical logical structure framed in abstract terms.
So our brains are basically tuned to spot social freeloaders.
It seems to be a core component of our social intelligence. And conversely, we also seem to have adaptations for detecting true altruists, people who are genuinely cooperative and reliable partners, which helps us choose good allies in the first place. The source mentions the adaptive problem of distinguishing fair-weather friends from true friends. Anyone can be nice when things are easy. The critical test of a friendship's strength, especially ancestrally, was whether someone would provide costly help when you were truly in need. That kind of costly signal indicates genuine commitment and forms the bedrock of deep, reliable friendships.
Okay, so reciprocity explains one-on-one cooperation. What about larger groups? Humans form teams, alliances.
Right, we form cooperative coalitions, groups of more than two individuals acting together for a common goal. This is fundamental to human social life. Large game hunting, warfare, defense, building projects, sharing resources. It's highly likely we have evolved psychological mechanisms specifically designed to facilitate forming, maintaining, navigating the complexities, and reaping the benefits of these coalitions.
But group living isn't all cooperation. There's also competition, conflict, aggression.
Indeed. And the evolutionary perspective on aggression and warfare treats aggression not as a single, simple drive, but as a complex set of strategies that evolved because they helped solve specific adaptive problems in certain contexts. The fact that aggression varies so much by sex, age, culture, or situation doesn't mean it's not biological. It means the underlying mechanisms are highly sensitive to cues that signaled when aggression was likely to pay off evolutionarily in the past.
And there are those well-known sex differences in aggression.
Yes. Very consistently across cultures, males engage in far more direct physical aggression, hitting, fighting, violence than females do. Females, while certainly capable of aggression, tend to employ more indirect or relational aggression. Things like gossiping, social exclusion, damaging reputations, manipulating social bonds. These patterns are found everywhere from modern Finland to traditional foraging groups like the Samadhi in Bolivia.
Why the difference? What adaptive problems might aggression have solved potentially differently for men and women?
Several recurring problems are proposed. Aggression could be used for resource procurement, basically, taking stuff from others by force. It's central to intrasexual competition fighting rivals to gain status or access to mates. Aggression can be a tool for negotiating status in power hierarchies. Successfully dominating others can lead to higher rank, especially for males in many contexts, think gang fights or historical warrior cultures. Though, as the source notes, context is everything. A professor punching another professor would lose status, not gain it. Aggression can also function in mate retention, particularly males using threats or violence to deter rivals or control a partner's behavior to prevent infidelity.
So aggression isn't random. It's deployed strategically in response to specific adaptive challenges like competition for resources, status, or mates.
That's the evolutionary framework. The specific contexts triggering aggression often map onto these problems. For male-male aggression, common triggers include threats to status or reputation, competition over resources or women, cues of being socially excluded or low status, like unemployment or being unmarried, which might trigger riskier strategies, and especially observing or suspecting rivals or attempting to poach one's mate. For female-female aggression, it often revolves around competition for desirable long-term mates, high-status males, defending their own relationship and access to the partner's resources, or fending off romantic rivals, frequently using those indirect tactics like gossip and social exclusion aimed at the rival's reputation or attractiveness.
And a most extreme form of group aggression.
Warfare.
Warfare, lethal coalitionary aggression between groups, is another area where evolutionary psychology offers hypotheses. Historically and cross-culturally, warfare is almost exclusively a male endeavor. Why?
Potential rewards for the winners. A key hypothesis, supported by some anthropological evidence like studies of the Yanomamo people in South America, is that victory in warfare historically led to increased sexual access to women for the victorious males. Yanomamo men who had killed in battle, called unokais, gained higher status and had more wives and offspring. The causes of wars were often explicitly stated as disputes over women.
So reproductive benefits could be a major evolutionary driver of male participation in warfare.
That's a central hypothesis. Supporting evidence includes the male predominance in war, men's greater focus on assessing fighting ability in themselves and others, the observed links between warfare success and reproductive success in some societies, and the fact that men tend to value traits like bravery, strength, and fighting prowess in their male allies, qualities essential for successful warfare. It suggests men possess evolved psychological mechanisms specifically related to coalitional combat.
Wow, okay. We've gone from individual survival instincts all the way to the potential evolutionary roots of warfare. It feels like evolutionary psychology touches almost every aspect of human experience. How does it manage to tie all these different areas together?
That's really its strength. It functions as a potential meta-theory for psychology. It offers a broad, overarching theoretical framework derived from biology that can potentially unify and make sense of findings from all the traditionally separate branches: cognitive, social, developmental, personality, clinical psychology.
Kind of like a grand unified theory for the mind.
That's the ambition, yes. It provides a different lens than many traditional approaches. For example, it directly challenges the old cognitive science assumption of a general-purpose mind. Instead, EP argues forcefully for that view of the mind as a collection of numerous, functionally specialized, content-rich mechanisms. Those tools we talked about, each tailored by selection to solve a specific adaptive problem.
And this specialized view helps explain that apparent paradox we sometimes see. Humans seem prone to all sorts of cognitive biases in lab tests, yet we navigate the complex real world pretty effectively. How does EP resolve that?
That's a fantastic question. Why do we seem irrational in experiments but rational enough to survive and reproduce? EP's answer is that our cognitive mechanisms aren't designed for solving abstract logic puzzle or probability problems under artificial lab conditions. They're designed to work well using the kinds of information formats and statistical regularities that were present in our ancestral environments. Our rationality is adaptive, tuned to the world we evolved in.
Can you remind me of that study about statistical reasoning that illustrated it really well?
Right, the disease prevalence problem given to Stanford students. When the problem was presented using probabilities, example, the probability of the disease is 0.1%, performance was terrible. Only about 12% got the right answer regarding the likelihood of having the disease given a positive test. But when the exact same logical problem was presented using natural frequencies, the way humans would actually encounter information ancestrally, for example, 1 out of every 1,000 people has the disease, accuracy jumped dramatically to 76%. And when presented visually with frequency icons, it was near perfect.
That's incredible. Just changing the format to match how we likely evolved to process information makes a huge difference. A bias in one format is actually efficient processing in another.
Exactly. It suggests our minds are designed to track frequencies of events, not abstract probabilities. What about something as fundamental as language? Is that seen as an adaptation? That's been a huge debate. Some prominent figures like linguist Noam Chomsky and biologist Stephen Jay Gould initially argued that language might largely be a byproduct of having a very large, complex brain. Like the brain got so powerful for other reasons, and complex language just sort of emerged, like heat is a byproduct of a light bulb. The source mentions some find this a bit vague or mystical.
Lacking a clear mechanism.
Right. The alternative view, strongly argued by people like Steven Pinker, is that language shows clear hallmarks of complex adaptation. It has intricate, functional design that seems specifically tailored for solving problems of communication, encoding, and decoding complex information with astonishing efficiency. It's hard to explain that level of specialized structure as just a side effect. Apparently, even Chomsky has somewhat moderated his view more recently, acknowledging selection likely played a role.
It shows how tricky it can be to distinguish adaptation from byproduct, even for something so central. How has EP influenced fields like social psychology?
Well, traditional social psychology has been fantastic at describing phenomena, conformity, attraction, altruism, prejudice, often through clever experiments. But it sometimes lacked deep theoretical explanations for why these phenomena exist in the first place. EP provides potential why answers by applying those core evolutionary theories. Inclusive fitness theory provides a foundation for understanding family relationships, nepotism, and patterns of altruism. Reciprocal altruism theory underpins our understanding of friendship, cooperation, gratitude, guilt, and cheater detection. Parent-offspring conflict theory sheds light on family arguments and sibling rivalry. Even theories like multi-level selection, the idea that selection can sometimes act on groups, favoring groups with more cooperative individuals, are being used to explore the evolution of morality, social norms, and large-scale cooperation.
So it provides the ultimate distal explanations for the proximate mechanisms social psychologists study.
That's a good way to put it. It offers a deeper theoretical grounding. EP also helps explain individual differences through concepts like life history strategies. The idea is that even with a shared universal human psychology, individuals might adopt different developmental pathways or strategies based on cues from their early environment.
How does that work?
The evolutionary theory of socialization by Belsky, Steinberg, and Draper is a key example. It proposes that early childhood environments, particularly cues related to resource scarcity and relationship instability, like father absence in the first 5 or 7 years, statistically speaking, might calibrate a child's development towards a fast life strategy. This involves expecting resources and relationships to be unpredictable, leading potentially to earlier puberty, earlier sexual activity, more short-term relationships, a quantity-focused reproductive strategy, perhaps linked with personality traits like impulsivity and extroversion.
So the early environment essentially tells the developing brain which strategy is likely to be more successful given those conditions.
That's the hypothesis that our evolved psychology includes conditional rules. If environment X, then develop strategy A. If environment Y, then develop strategy B. It helps explain variation within a population.
Okay, last big area. What about culture? A common criticism of evolutionary approaches is that they ignore culture. How does EP deal with culture and environmental variation?
That's a really important point, and EP definitely does not ignore culture. It seeks to explain it from a biological foundation. It argues that simply saying it's culture isn't an explanation, it's just describing the phenomenon, group differences. We need to understand the causal processes producing those differences. EP proposes two main ways our evolved psychology interacts with environments to generate cultural variation.
What are they?
The first is evoked culture. This is when different environmental inputs trigger different responses from the same underlying universal psychological mechanisms. So everyone has the mechanism, but it produces different outcomes depending on the local ecology.
Give me an example.
Food sharing norms. In cultures where hunting success is highly variable, like the Ache in Paraguay, strong norms of meat sharing emerge because everyone benefits from pooling risk. But gathered foods, which are more predictable, might be shared less. Compare the Kung San, with high food variants, who emphasize sharing heavily, versus the Ghana San with lower variants, who hoard more. The environmental variable, food variance, evokes different sharing strategies from a universal psychology sensitive to risk and reciprocity. Another example. Parasite prevalence. Cultures and regions with historically high levels of disease-causing parasites tend to place a higher value on physical attractiveness in mates as a potential signal of health, and also tend to exhibit higher levels of conformity, perhaps because deviating from traditional practices is riskier in pathogen-rich environments. The environmental threat evokes specific cultural values and behaviors.
Fascinating. The environment dials up or down certain universal tendencies. What's the other mechanism?
The second is transmitted culture. This is the more familiar idea of culture as beliefs, values, skills, and traditions that are learned from others through social learning, imitation, teaching, language. EP contributes here by asking, why are certain ideas, beliefs, or practices learned and transmitted more easily or successfully than others? What makes an idea catchy?
Does it tap into our evolved psychology somehow?
Exactly. Ideas that resonate with our evolved motivations, like status seeking, mate attraction, fear of contaminants, or are easier for our evolved cognitive systems to process and remember, or provide solutions to recurring adaptive problems, like using spices to preserve food, as we discussed, are more likely to spread and persist culturally. So EP doesn't see culture as separate from biology. It sees culture as arising from and being shaped by the interactions between our evolved minds and our variable environments and social worlds.
Okay, wow. That really ties it all together. We've journeyed from Darwin's first hints about psychology's new foundation, through the core theories of selection and investment, explored the challenges of survival, the complexities of mating, the intense dynamics of family and kinship, the push and pull of group living, and finally how this evolutionary perspective aims to integrate all of psychology and even explain culture.
It's a truly ambitious and I think incredibly insightful framework. It doesn't have all the answers, of course, in their ongoing debates, but it provides this powerful lens for asking fundamental questions about human nature and getting potentially deeper answers about why we feel, think, and behave the way we do. It really can be a shortcut to understanding the deep history embedded within us.
And as you listening reflect on all this, the mating preferences, the family conflicts, the cooperation and competition, maybe think about how this perspective could shift how you see things in your own life. Could it help you understand your own impulses better? Or maybe make sense of patterns you see in your relationships or at work or even in society at large?
It definitely offers a different angle, a way to look beneath the surface explanations we usually encounter.
And here's a final thought to leave you with, really building on that idea of our ancient minds in this modern world. We talked about the mismatch, our psychology evolved in ancestral environments, savannas, small bands. But we now live in this incredibly novel world of cities, technology, social media, global connection. So the question is, how are our Stone Age minds actually coping with, or maybe struggling with, this 21st century reality they weren't designed for? And maybe, just maybe could, understanding these mismatches where our evolved tendencies clash with modern life help us design better environments, better institutions, or even just better personal strategies to improve our well-being in a world that's so different from the one that shaped us.